Hey guys, I want to do a little derivation of the equivalence of Euler's form of a complex number to this modulus argument form. Okay, and of course, the cosine plus I sine theta is also equal to cis theta. So kind of keep that in mind as we go through this. Okay, so I'm gonna take you from e to the I theta and show you that there is equivalence here. Okay, so first I'm gonna start with a Maclaurin series for e to the x, which we know if we go out, let's say we find the fifth degree polynomial representation of e to the x. That'll be 1 plus x squared over 2 factorial, x cubed over 3 factorial, x to the fourth over 4 factorial. Continuing on, I get x to the fifth over 5 factorial. Now, what I'm going to do here is I'm actually going to, now using that, find e to the ix. So I'm going to do a substitution. Everywhere I see an x, I'm going to plug an ix, right, in each of these independent variables. Okay, so what that'll equal is 1 plus ix plus ix squared over 2 factorial plus ix cubed over 3 factorial. Might as well write them all out, right? Ix to the fourth over 4 factorial and ix to the fifth over 5 factorial. Okay, let's do a little work to simplify this. That'll be 1 plus ix. Now I squared is negative 1. Therefore, we will have a negative x squared over 2 factorial. Okay, I to the third is negative I, so that'll give us a negative ix cubed over 3 factorial. I to the fourth is a positive 1, so that'll give me a plus x to the fourth over 4 factorial. And I to the fifth is equivalent to I, thus I will get plus ix to the fifth over 5 factorial. Now I'm going to group the real components of this polynomial, which of course you'll see right here. Okay, and doesn't that look familiar? If you remember your Maclaurin series, that's actually cosine of x. Okay, and then I'm going to look at my imaginary portions. So that's ix, negative ix cubed over 3 factorial, positive ix to the fifth over 5 factorial. That right there, if I were to factor out an I, would be I times sine x. And that is just outstanding, right? Outstanding that e to the ix is actually approximately equal, depending on the length of the polynomial, but it is approaching cis x. Now, look at that. Isn't that, of course, just a change in independent variable as we can see above. Now, if I were to multiply, right, both of these by some constant, of course, then I could see de Moivre's theorem, excuse me, not de Moivre's theorem, the equivalence of Euler's form, which is r e to the I theta, which is equivalent to modulus argument form with the same values r and theta. All right, guys, that is one cool deal there, that e to the I theta is equivalent to cis theta. Use it. Don't lose it. See you in the next video.